Welcome back to Advent of Code 2024. Day 2. I have solved that. We're going to look at it and see what's up. We have red-nosed reports. The lore is on the screen for your reading pleasure. Basically, we're looking at the red-nosed reactor, which is some power plant or something like that. And we found a whole bunch of reports. So the levels of the reactors are changing over time. So this is one report on one line. So the levels go from 7 to 6 to 4 to 2 and to 1. And what we need to do is find out how many of these reports are safe. To determine if a report is safe, both of these conditions have to be true. Any two adjacent levels must differ by at least 1 and at most 3. And that can be positive or negative. And all of the levels either are all increasing or all decreasing. So we have to be going all up within like the right range or all down. But we can't go too far up, we can't go too far down, we can't stay the same, and we can't go up and down. So for the test input, you can read which ones are safe and unsafe. These are all trending down. These are all trending up gradually. This is trending up too much. And these three numbers, these go up and down. So that is unsafe. So for our algorithm, what we need to do is find which ones are safe, and we should find that there are 2. Let's look at the solution for part 1. We are going to look at our test input, and we're going to do the same thing as we've done before. We're going to split the input data by every new line to get an array of strings, and then loop through that array of strings and find out if this report is safe. We will increment the safe report number. Very simple. So to find out if a report is safe, we're actually going to test if it's unsafe. And if we find that it's unsafe, then we just go to the next one. But if we get to the end of our test and we didn't find that it's unsafe, it's safe. So this whole thing, this all tests if it's unsafe. And if we don't find anything, it's safe. So we'll take our report, turn it into an array of numbers. We'll look at the very first and second numbers. So in the first case, we'll look at 7 and 6. And we'll find if those numbers are the same and those levels didn't change, that's not allowed. So we'll continue to the next one. So then the idea of what's going on here is that we want to know, are the levels trending up or are the levels trending down? Okay. If the levels are trending up, then if I find any changes that go negative, that's bad, right? So the level changes must be within 1 to 3, positive 1 to 3. But if my data is trending down, if my first number is bigger than my second number, then the safe changes actually range from -3, which is the minimum, to +1. So that's what I'm determining here, right? Which way is the data trending? And then I have a very basic for loop, except I'm not starting at 0. I'm starting at 1. We are saying that for every iteration, j equals I minus 1. And in this case, for any iteration in the loop, we're going to find that j is on the left of I. The difference between those values will be levels I minus levels j. And so if that difference falls outside of the safe level changes, if it's less than the minimum or if it's greater than the maximum, then that's unsafe. And in that case, we will continue the outer loop. Okay, if I were to use the continue keyword here, we would continue this loop. That's not what I want. I want to continue the outer loop. So we will use named loops. Very cool feature. So if we get through all of this logic and we never found an unsafe level change, that means the whole thing is safe. Let's look at the output, right? This says this first report was safe like we expected. This last report is safe like we expected. And we get 2 total. Our real input looks like this. And when we run our algorithm on the real input without the logging, we get an answer of 559. And that ran in that amount of time. And 559 is my correct answer. And now for part 2. We didn't like how few safe reports there were. What we want is more safe reports, so we're just gonna pretend like some of the numbers aren't there. We're gonna run the same rule set, same algorithm as before, except in this case, we're allowed to tolerate a single bad level. What that means is that for this report, which was previously unsafe, we could just conveniently remove or ignore 3 so that our report becomes 1, 2, 4, 5, which is safe according to the previous rules. Then the question is, right, if we can ignore any of the numbers, which one do we ignore? The brute force solution, basically just take a report, test if it's safe. If it's not, ignore the first number. If that's not safe, ignore the second number, and so on. What we can do with this algorithm is we should expect now to have 4 safe reports where sometimes we still just can't get around it. And now the solution of part 2 is pretty much the same with a minor change. We're going to take our entire algorithm that we saw earlier and shove it into a function called it test report. And that's just going to run on an array of numbers. Again, we're finding what the trend is. And instead of incrementing some number, we're going to return true if the report is safe and false if it's unsafe. And then for the main logic, we're still looping through all of the reports, except we are going to turn them into an array of numbers first, and then just test if it's safe. Okay? If it's safe, then we'll do the incrementing like before. Now, instead, if it's unsafe, we're not going to continue the loop. Now we're going to test, is the first number able to be ignored? Oh, can we ignore the second number? That's what this does. Let's loop through every index. And then this is going to take one slice of the array over here plus another slice over here. And so we're sort of sliding it this way. Okay, that's what this does. And so we'll test the report, giving it different arrays. And if any of those are safe, we will add one to our count and then go to the next report. When we run our algorithm on the test data, we get 4 like we expected. And when we run our algorithm on the real data, we get 601 in 3.8 milliseconds. And that was the correct answer. That brings me to a total of 4 stars for the year. Number 3 is available, so I'm going to go and get started on that one.